Welcome, Agent. Consider this your tactical explainer briefing. Your mission today, should you choose to accept it, is extracting maximum marks from the highly hostile, incredibly high-pressure environment of the Cambridge Computer Science exam. We are talking about getting in, getting the marks, and getting out in 20 minutes or less per major section. And listen, whether you are operating under syllabus code 0417, 0478, 0983, 0984, 2210, or our primary target for today's deep dive, the rigorous 9618 AS&A level, the battlefield is exactly the same. You are a secret agent of logic, and your absolute worst enemy out there is ambiguity. To really understand the stakes of this mission, I want to introduce you to two fellow operatives who recently completely failed their missions on a real Cambridge Computer Science past paper question. First up, we have Alex. Look at Alex's paper on the left side of your mental split screen right now. Alex overloads the page with raw computer science facts. Basically, Alex is doing a massive data dump of every single thing they memorized from the textbook, but they are providing absolutely zero analysis. It's just a wall of text. Now on the right side, we have Sam. Sam rushes. Sam panics at the clock and ignores the mission parameters entirely, completely missing the specific command word requirements. Sam is losing massive points despite actually knowing the technical material. We are seeing a literal sea of red pen marks on both of their papers. It's a disaster. But today we are going to fix that.
So, what is the exact difference between a B and an A-star grade? Well, the senior examiner explicitly confirms that the difference between an average, possible B grade, and that top-tier A-star success almost always comes down to mastering one specific battlefield. Topic 6.1, Data Security, Privacy, and Integrity. This is where the red pen hits the absolute hardest. Listen, it is not just about knowing how to code, it is about knowing how to protect the data that your code processes. When examiners sit down and look at responses from candidates like Alex and Sam, they see a fundamental misunderstanding of the rules of engagement. Alex writes paragraphs and paragraphs of complex code syntax when the question actually asks for a security evaluation. Sam, on the other hand, defines privacy when the question explicitly asks about integrity. These are fatal errors in the field. To get that A-star, you have to decode the command words perfectly, and you must deploy exactly the right theoretical concept at exactly the right time. There is zero room for guesswork here. We have intercepted intelligence straight from the Cambridge Principal Examiner reports, and it reveals a critical trap. They state this incredibly plainly. Candidates consistently confuse key terminology. This right here is the tripwire that takes down thousands of smart students every single year. They constantly, repeatedly confuse these three foundational concepts: security, privacy, and integrity. Now, to the untrained civilian on the street, these words sound like synonyms. They sound like the exact same thing. But to a master computer science agent, they are entirely different protocols. When you confuse them, the examiner literally stops reading and starts deducting marks. This is exactly what happened to Sam. Sam wrote a genuinely beautiful, highly detailed paragraph about password protection when the examiner asked about data corruption during transmission. Sam answered the wrong question beautifully. You cannot afford to make this mistake, and that is exactly why we have to break these concepts apart, layer by layer, right now. Let's move into Section 1, Decoding Core Principles. We're going to establish a solid theoretical architecture right now by clearly defining your primary targets so you never fall into that trap. To absolutely conquer these core principles, we are going to overlay what I call the PEAL framework onto every single answer you write from now on. PEAL stands for point, evidence, explanation, and link. Top students do not just throw random facts at the page and hope something sticks. They structure their answers with absolute military precision. You make your point. You back it up with evidence directly from the scenario provided. You explain the technical mechanism behind it, and finally, you link it back to the prompt to seal the deal. Let's apply that framework to our first target, data security. Think of data security as the foundational armor of your entire system. It is all about the mechanisms and strategies used to protect data from unauthorized access, modification, or destruction. It's all about keeping the bad guys out. We're talking firewalls, complex encryption, biometric scanners. So if a hacker tries to breach a network, your point is data security. Your evidence is the specific vulnerability mentioned in the text. Your explanation details exactly how an encryption key scrambles the data to make it unreadable, and your link ties it all directly back to preventing unauthorized access for that specific company. Using this PEAL framework gets you all 4 marks, not just one measly point. Next up is data privacy. You have to understand that this is not about hackers breaking in from the outside. This is entirely about what the people who are actually allowed inside the system do with the data. Privacy focuses heavily on handling data legally and ensuring it is exclusively utilized for its authorized intended purpose. Think about major legislation like the Data Protection Act or GDPR. For example, if a hospital shares a patient's confidential medical records with a third-party marketing company without getting explicit permission, the hospital hasn't suffered a security breach at all. No one hacked them. Instead, they have committed a massive privacy violation. Examiners absolutely love to test your understanding of these ethical and legal dimensions. So you need to keep that distinction between security and privacy incredibly sharp in your mind when you're reading the exam prompt. And this brings us to our third major target: data integrity. Integrity guarantees the data itself has not been altered or corrupted by errors or malicious action during transmission or storage. Let me be clear, this isn't about someone stealing your data, and it isn't about someone selling your data for profit. It is literally about a 1 turning into a 0 while traveling across a faulty network cable. It's about a hard drive sector spontaneously failing. When an examiner asks how to ensure an uploaded file matches the downloaded file perfectly, they are looking for integrity protocols. They want to see words like parity checks, checksums, or cryptographic hashing. Remember Sam's huge mistake earlier? Sam talked about passwords here, but passwords only stop hackers. They do absolutely nothing to stop a sudden power surge from flipping a bit and completely destroying your data's integrity. Do you see the difference? It's night and day to an examiner.
Top-tier agents don't just state generic facts. They build cross-topic connections, which examiners explicitly state will unlock significantly higher marks. This is the exact moment where you transform from a standard average student into a top-tier A-star operative. You don't just memorize the definition of integrity and parrot it back. No, you connect integrity to the database topic by discussing referential integrity and foreign keys. You connect security to the networking topic by discussing things like packet sniffing and SSL/TLS handshakes. When the examiner is grading your paper and sees you pulling in deep technical knowledge from syllabus code 9618's other modules to perfectly answer a 6.1 question, they immediately recognize master-level understanding. You are no longer just regurgitating facts. You are synthesizing information like a true computer scientist.
Before we continue to our methodology section, I want to give you a quick memory hack. But first, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the hack. When you sit down in that freezing cold exam hall and the pressure violently spikes, your working memory shrinks. It happens to everyone. So create a mnemonic using the first letters of key terms, SPI for security, privacy, integrity. I want you to physically write SPI at the top of your rough paper the absolute second the exam begins. Whenever you read a scenario, point your pen to S, P, or I to lock in your context before you even start writing your Peel paragraph. It grounds you, it forces you to stop and think, and it completely stops you from making Sam's rushing mistake. Let's move straight into Section 2, the method mark strategy. Let's see exactly how procedural execution earns you incredibly valuable marks, even when things go wrong. This right here is where those devastating red pen marks on Alex and Sam's papers actively transform into beautiful green check marks. Cambridge examiners actually want to reward you for your logical flow. They are looking for reasons to give you marks. If you only write down the final output of a complex algorithm and that final output is wrong, you get 0. But if you clearly show the method, you can salvage up to 80% of the points. Systematic processing requires this specific standardized sequence. Step 1, identify key elements in the prompt. Literally highlight the command word like evaluate or describe. Step 2, apply relevant principles. Ask yourself, is this an S, P, or I problem? Step 3, execute analysis. Start building your point and evidence. Step 4, verify results. Does your explanation actually truly answer the prompt? Step 5, present format. Ensure your link ties it all up neatly. When you force a messy data dump answer into these 5 steps, it naturally and automatically structures itself into a high-scoring methodical response.
So, the crucial point here is that your algorithmic thinking must explicitly showcase decomposition, structure selection, code implementation, and rigorous testing. And this applies whether you are writing lines of pseudocode or whether you are evaluating a high-level security protocol. You always have to decompose the threat first. What exactly is the hacker doing? What specific data structure are they targeting? Are they overflowing an array? Are they injecting SQL into a database text field? Break it down. Then you explain how to implement a defense, and crucially, this is where everyone loses marks, how do you test that defense? Top marks always go to the agent who takes the time to explain how to verify the solution actually works in the real world. We are now entering Section 3, Examiner Warnings and Traps. You must learn how to navigate the major traps examiners actively lay out for you. But first, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, the principal examiner reports flag these 3 critical errors that consistently destroy candidate scores year after year. Mistake 1, ignoring edge cases. Mistake 2, missing boundary conditions. Mistake 3, failing to apply context. We are going to do a mental find the flaw challenge right now. Imagine a 60-second timer ticking down on your screen. Here is a sample paragraph from a student. To protect the database, we will implement a validation check that ensures passwords are more than 8 characters long. Time's up. Can you spot the fatal flaw in that logic? The flaw is that they completely ignored the boundary condition. What happens if the password is exactly 8 characters long? The logic fails, the system breaks, and you lose the mark. Furthermore, they didn't apply the specific context of the company mentioned in the prompt. Examiners absolutely despise generic answers. If the exam prompt is about a local veterinary clinic, your answer better specifically mention protecting animal health records and client payment details, not just protecting data in general. Context is king. Never, ever provide a rote-memorized definition when the exam specifically demands you apply that definition directly to the unique scenario provided. Let's look at the difference. On the left side, we see Sam's old, rushed, panicky answer. Encryption stops hackers from reading the file. That is a contextless, zero-mark disaster. It tells the examiner nothing. Now, on the right side, look at our highly focused, peel-structured answer. To secure the veterinary clinic's cloud storage, that's the point, asymmetric encryption should be deployed on all patient records. There's the evidence. This ensures that even if a cybercriminal intercepts the transmission, without the private key, the ciphertext remains completely unreadable. That's the explanation. This directly satisfies the legal requirement to prevent unauthorized data exposure. And that is the link. Boom, maximum marks extracted with surgical precision. Moving to Section 4, Evaluative Thinking for Master-Level Extraction. Now, what's really interesting about this next concept is exactly how it bridges the massive gap between a B grade and an A star through higher-order evaluative thinking. An average middle-of-the-pack agent can tell you what a security protocol does, but a master agent can tell you exactly why one protocol is vastly superior to another given a very specific set of real-world constraints. When the command word on the paper is evaluate or discuss, the examiner is actively testing your ability to weigh multiple options against each other. You cannot just list the pros and cons in a bulleted list. You must make a firm judgment call. To truly evaluate alternatives, you must map out similarities and differences, you must use comparative connectives, support it all with evidence, and justify your final recommendations. For example, if you are asked to evaluate biometrics versus passwords for a high-security bank vault, you must identify similarities first. Both restrict access. Then you must use connectives, words like however, conversely, or whereas. You might write, passwords are highly cost-effective to implement, however, biometrics provide a non-transferable physical security layer. You then support this with technical evidence. Finally, you must provide a conclusion. Therefore, despite the significantly higher implementation cost, the bank's extreme security requirements make biometrics the absolute necessary choice. That right there is how you completely dominate the paper. Whenever you're evaluating any data security approach, I want you to run through this final checklist to ensure you are analyzing all the trade-offs and acknowledging the real-world limitations. This is your ultimate cheat sheet for the exam. Rule 1 is command word decoding. Never, ever answer a describe question with an evaluate response. You are just wasting time. Rule 2 is peel framework application. Structure every single paragraph meticulously. Rule 3 is the time management matrix. Allocate your 20 minutes strictly and move on when the time is up. And always consider the limitations of every system you propose. If you suggest top-tier, heavy-duty military encryption for a simple, lightweight mobile game app, the examiner is going to severely penalize you for ignoring the massive trade-off of processing speed and battery drain on the user's mobile device. Like I said before, context is absolutely everything.
The examiners have issued a massive alert for you, and you need to hear this loud and clear. If you don't explicitly define terms like privacy or integrity before launching into a huge extended response, you will bleed marks.
Do not assume for a second that the examiner knows that you know what it means. You have to prove it in the very first sentence. Students who implement these structured, logical strategies see massive improvements purely through applying the correct method. We saw Alex and Sam's answers completely transformed by just stopping the rush, stopping the massive data dumps, and organizing the logic. Speaking of which, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Your mission briefing is now complete, Agent. You now have the advanced tactical tools to decode the prompt, structure your logic flawlessly with a PL framework, and evaluate complex security trade-offs just like a master agent. The only question left is the one right here on the screen. When you sit down in that exam hall and that clock starts ticking down, will you fall back into the fatal trap of memorized data dumps and rushed generic answers, or will you execute the method perfectly? Prepare your strategy, lock in your core principles, and go ace that mission. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGC to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGC and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.